Hello friends, welcome to the 6th tutorial of SAP 2000 V14. Today I am dealing with a shear wall and its interactions. And the example which I am taking from the help options is problem N. You can go to help, contents and index, example problems. You can just press plus over here and you can go to problem number N. So here we are dealing with a shear wall interaction, frame and shear wall interactions. So if you see this, we have a 3 bay and a 6 floor unit structure and of a height of individual floor height of 12 feet and a bay width of 20 feet and a force acting at 10 kilonewtons and incrementing towards the extreme floor. So today I am dealing with this example. First, change the unit to keep feet, and I am following all the instructions as per the examples, and after all the examples are done, I will start with the tutorials on dealing with real life structural problems. So go to File, New Model, 2D frame member. So let us take number of stories as 6 stories and number of bays as 3 bays and width of 20 feet. You can just say OK. Now close the 3D view, and if you see here the bubble size is not visible. So what I do is go to define coordinate system grid, modify show system. You can just take it as 3. So you can see the bubbles which I am speaking about. If you see here, you can see A, B, C, D, and in the previous case there is no bubbles that can be seen on the screen. So here now if you see the diagram properly, you have a one more wall at a distance of 5 feet and 12 feet from this plane, from this vertical column member. So what you can do is you can go to define coordinate system grids, you can go to modify show systems, and here you can enter the commands now. So it is E, type it as capital E, and if you observe the drawing properly here, let me put this aside and let me take it over here. So if you observe this properly, now what I'll try to do is, this frame is initially at 30. Let us imagine that this is at minus 30 and this is at minus 10 and this is at 10 and this is at 30. So I am giving a frame which is at the back side of this. So the spacing here would be minus 35. Minus 35 will be at this, will be of this column member, and minus 35 plus 12 will be to this column number. Okay, so I hope you have understood it. So this is let us take that this has minus 30, so this is minus 35 and this has minus 47. So you can go for E, you can just say it as minus 35, you can just type P, show and end, and next is A, B, C, D, E, and next I'll go for capital F. So this is at a distance of minus 47. So let me come back to this diagram again. So if you understand this, so this is at 30. So let me rephrase it again, just a second. Let me rephrase it, reorder the ordinates. Sorry, before doing that, let me say primary, show, end, and now say you can reordinate. Now if you understand this picture properly, this says the complete story. So this is minus 47. So imagine that this is minus 47. The next line is 35. So this is minus 35. Minus 35 minus 47 is a spacing of 12 feet. 12 feet, 5 feet, 20 feet, 20 feet, 20 feet. Okay. So this is how it has taken. Let me close this window. Say OK. Say it as OK. Now we can see the things acting over here. So now what you can do is you can assign a shear wall to all these 6 floor members. So what I'll try to do is I'll go to quick draw area element command, and so put this aside, and now we can just press on the places where the shear wall is being assigned. Okay, and now if you can just go to set select mode, and if you want to see the wall here, you can just go to set display options, you can go to fill objects, and you can just say OK. So this is a shear wall which I have just assigned to the member. So what I'll try to do is I will try to give the label numbers, labels and areas, and next I'll say OK. So these are the labels which I have assigned. So what I will try to do is, since the labels are very small, I will try to maximize the label size. So you can go to options, dimension tolerances, you can go to minimum graphic font size, you can just type as 6, you can just say OK. Now if you see the increment of the numbers that have been assigned to the points, these are the joints and these are the areas. Since there are no areas over here, you cannot see any numbering on these points. And now what I try to do is I will try to assign restraints to the member. So go to members 29 and 30, and now what you can do is you can assign the joint restraints. Go to assign joints and restraints, and what you can just say OK. And now what I'll try to do is I will try to next define the material properties of the element. So however the units are in kip inches Fahrenheit. So what I'll try to do is I change the unit here. Now I'll go to defining of the material, define materials. If you see this tabular column over here, you have all the members specified. This is a concrete member and this is a steel member. So what you try to do is you go to 4000 psi. So approximately 1 Newton would be around 146 psi, 146.6 psi. So what I'll try to do is I'll try to modify this. So I'll define this material as concrete member, and this as 3600, and you can just say OK. So this is as per the example given in the example number, problem number N of the help options. Okay, so I'll just say it as OK, and you can just say it as OK. And what I'll try to do is I will try to define the column members and the beam members to this. So what I'll do is I'll go to define section properties, framed sections. Now I'll go for add new property. You can go to you can go to concrete, since you are designing a concrete structure. Go to rectangular member, you can say it as beam member, you can say it as a beam member. So the dimensions of the beam is 24 inches of depth and 12 inches of width, and you can just say OK. And however, a simple thing if I want to remind you is you can go to concrete reinforcement and you can design the depth of the reinforcements. So however, I'll try to not go into this matter, because however I'll be teaching in the later tutorials of how to design a beam elements. I'll just say OK, and I'll just say it as OK. Now the beam member has been assigned. Again go to add new property, you can go to rectangular member. So you can say it as column, COLUMN. So you can say it as column. The column dimensions as per the example is 24 inches by 24 inches. That means it is a square column. So you can see soon after I click OK, you can see the change over here. Okay. So now the column members have been assigned. But now I want to define the thicknesses of these shear walls. So what I'll try to do is what I'll try to do here is define. You can go to section properties, area sections. You can go to you can go to the ASEC and you can say just go for modify show section, because you have already selected the member over there. That is why I have selected the same member over there. So what I'll try to do is I'll try to specify the thicknesses of the wall sections over here. So let the member be of 6 inches by 6 inches of thickness. That means almost 15 centimeters of thickness. So let ASEC be same, because while I am selecting, okay, let me close this. While I am selecting, I have given ASEC for these members. So please be careful with the selection process. So now I have specified members. Now I want to give the column members, since the column member should be assigned and later on the beam should be assigned to the structure. So far we came up with the designing of the frame, and then I went to the defining of the next frame, and where I have assigned the shear walls to the member, and then I have defined the column members and the beam members and the concrete properties. And now I want to assign all these things to the structure. So what I'll try to do is, you can select the column members. You have an option of select using intersecting lines. So whatever lines this member will select, it will automatically go through. So let me say I want these columns. So what I try to do is, you can just click your left finger on the mouse, and where you can select the column members here. Okay, so please be careful while doing this selection. And now you can double click the member again. Now the column members have been selected. Now we can go to assign frames, frame sections. You can say them as columns. And now the column members have been selected. Don't worry that FSEC has been selected. I will come back to that in a while. So again, now we want to assign the beam members to the structure. So what I'll try to do is, I'll try to start here. Double click. So now you got the beam members. Now we can go to assign frame sections, and you can say them as beam members, and you can just say OK. Now the beam members have been selected, and now what we'll try to do is joints to the members. So what I'll try to do is, I will select all the members by windowing, or either by selecting all. Now all the members have been selected. So if you observe one drawback here, I want to give constraints to the member, but constraints will be given only at the joints. But now all the members have been selected, so please don't go for all command right now. So clear all. Now what I'll try to do is, I'll try to just window this, so only the joints will get selected. So now we can go to assign menu. You can go for joints, constraints, and you can go for diaphragm. In diaphragm you can go for add new constraints. You can say Z as OK, and you can just say check the assign to different diaphragm constraints to each different select Z levels, and you can just say OK. And before that, you can change the name if you wish to, but however I will try to modify this, because as per the example it is DIA PH. So I'll just go for DIA PH, and now I'll say it as OK, and now it's OK. Now what I try to do is, I try to select the joints of the members, that is, but what I'll try to do here is, I will try to give a simple detail of this, because what they are doing is, if you see this diagram properly, you have 1, 2, 3, 4, 5 and 6. So at these points you have point loads acting, but I'll try to give you a simple thing. So first try to go to joint 32. Now we can go for assign, you can go for joint loads, you can go for forces, and you can say on the force and the x direction a 10 kilonewton load is acting on the member. Say okay. Now you see the 10 kilonewtons is acting on this member. Similarly, select 34, again go to assign joint loads, forces. Now 20 kilonewtons is acting on the member. So just say okay, and so on, 30, 40, 50 and 60. Sorry, don't get tired, it's a bit lengthy process, but however you'll try to speeden up if you're following all the examples which I have said to you. It's 40. Please try to watch my further few back tutorials which I have taught, so that the process will be much easier. Now we can go to joint loads, again forces. If you can say 50, and the last floor assign joint loads and the forces is 60. And now you can just say okay, and now the forces have been assigned to the member over here. So if you want to clear all the loads acting on the member, so that they might cause you some distractions, so what you can do is you can just go for the show undeformed shapes. Okay, there is some misunderstanding in the thing. So what I'll try to do is determine the shear carried by the walls, by wall and by frame at second level and the sixth level. So second level will be basically this level, and the sixth level will be basically this level. So what I'll try to do is I'll try to deselect this, and I'll try to assign the restraints over here. Basically the problem with the examples, there might be some changes, but however I'll try to change them, and so that you can understand much better. So now we can go to assign to groups. Now we can go to add new group, and you can just give it as sixth wall. Now you can say it as okay and okay. And now what you can do is you can select all the members, or you can go to the second one, that is 39, 31, 32 and the second frame. Now we can go to assign to group, you can go to add new group, you can say it as second wall, and just say okay. And now this is a frame, so I'll try to select all the frame members over here, frames, and I'll try to select all the columns over here. So by selecting this, assign to group, you can say add new group, you can say it as second, it is frame, I think so, it's a frame, second frame, just second, yeah, it's second frame, and you can just say okay. And now you have the sixth member over here, so now you can select the joints over here, and you can select the columns. So this would be assign to group, add new group, I'll say this as sixth frame. So now the frames have been assigned, so I'll say it as okay and okay. And now the most of the work has been completed, and now what I'll try to do is I'll try to uncheck all the all the labels I have assigned. So labels, just say okay. Now everything has been cleared up. Now what you can do is you can go define, you have an option here, section codes. So you can go to add section cut. So in this section cut, what you can do is you can type second frame, and section group would be second frame, and you can just say okay, and again add section cut again. Now what you can do is you can go to the second wall, this second wall, just say okay, and now again go to add section cut. You can go to 6th frame and you can go to 6th frame, and again you can go to add section cut. Now we can go to 6th wall, you can say group 6th wall, just say okay, and now it's okay. So before that, please try to save the file, say Ctrl S, will give you the thing. I just say it as shear wall and just save, and I'll try to analysis, set analysis options. I'll go to XZ plane, just say okay, and now I'll go to run the analysis. You can go to analysis, run analysis, or you can just say F5 on the keyboard. So don't run this model analysis. Go to run, do not run the case, and now we can run the dead load case, however. So go to run now, now the thing has been obtained. Now the deflections have been obtained for the entire wall. So what I'll try to do is I will go to display, show tables. Now we can go to structure output, or you can go to plus option here. You can just click on the plus option here. Now we can go other output, sorry, you can go to other output files. Now we can say now we can click on the tables, and now we can just say okay to see the table results. Now if you see, these are the deformations applied in the member. So what I'll try to do is I'll try to close this. I'll try to change these units into kip feet so that you can understand the forces acting on the member. Let us see the animation if you are interested to see the animation of it. This is the animation that goes on in the structure. So I'll try to stop the animation for the wind load that is acting on the members. I'll go to again display, show tables, structure output, plus options, again select the section frame analysis. Section frame analysis, you can just select this, and I can just say okay. Now we can see the force acting on the member, that is in static F1, these are the forces, and F3, these are the forces, and the moments acting on the member. However, I'll try to come back to all these explanations after completing all the examples. I'll just say done. So this finishes the tutorial of the shear wall of example problem number N on the help option. And thanks for watching these tutorials. Please leave a feedback, and I will try to get better with the suggestions which you give to me. And I am thankful for watching this video. Thank you. Have a nice day.